Okay, in this video we're going to take a quick look at acceleration. So, what is this idea of acceleration? Well, probably so far you've probably just dealt with it in terms of or thought of it as speeding up. That's basically correct, but we're going to look at doing a few calculations with it. So how can we work out our acceleration? Alright, let's have a look. So we've got a triangle here again. So the formula for acceleration that will be given to you on the exam paper will be acceleration with a little a here equals, and it will probably have a triangle, which just means a change in velocity. So sorry, that's a little v. Draw that a little bit better. Alright, so acceleration is a change in velocity over time. Now let's just digest that a little bit. Let's have a look at what that means, and it may actually be over a change in time here too. So a change in speed over a change in time. Well, if you're speeding up, how could we measure that? Now we kind of make sense that when we looked at speed, your speed is meters per second. It's the number of meters you travel in each second. Or, you know, if you're driving your car, it's kilometers per hour. If you're traveling your car at 60 kilometers per hour, at a constant speed of 60 kilometers per hour, well, it means you're traveling at you'll cover 60 kilometers every hour. Well, how could we measure acceleration? Well, let's think about this for a sec. So if you were going 60 kilometers per hour, but then you put your foot down on the gas pedal just very slightly, and let's say you sort of slowly, let's say you're driving at 60 and you slowly sort of your speed starts to creep up and up and up. And let's say every hour, after every hour you find yourself going 10 kilometers faster than you were before. So you started at 60, and an hour later you've crept up to 70, and an hour later you've crept up to 80 kilometers per hour, and an hour later you've crept up to 90 kilometers per hour, and an hour later you've crept up to 100. What is your acceleration? Well, we could say your speed is increased by 10 kilometers per hour each hour. So 10 kilometers per hour per hour. And so it's the same here when we look at velocity. Our acceleration is velocity per time. We remember velocity is in meters per second. And so now it's meters per second per second. So our acceleration is measured in a unit. The standard unit is meters per second, and we use a little -2 here because it's meters per second per second. So you could think about that again. Maybe let's say if you were traveling at 10 meters per second, and every second you were increasing that by 1. So you went 10 meters per second, and then 11 meters per second, 12 meters per second, 13 meters per second. Each second you got faster. Well, your speed would be increasing by 1 meter per second each second. So acceleration just adds another per second. We've got a little -2 here to that value. So if we're calculating acceleration, it's the change in velocity divided by the change in time. Now we can also rearrange that. Sometimes you'll need to use this formula to work out, for instance, the change in velocity, the change in speed. So if we could have, in that case, the change in velocity is going to be equal to acceleration times time. Or we could rearrange it to find the time. So time will be equal to, so we're taking the time here now, is going to be equal to our velocity divided by acceleration. Our velocity divided by acceleration. So just be aware of that. I think that the key bit here, you probably will find using this triangle isn't too tricky. Key thing to remember is your unit here for acceleration is meters per second per second. So slightly different than speed. The other thing to realize here is the velocity. The triangle is actually quite important here for the change in speed. Most students will pick up on the change in time if it's a change in, but with the speed you may have to work out the difference. If you started going at 10 meters per second, and you get faster by 1 meter per second, so then you're going 11, 12, 13. Well, how fast you were going to start with isn't actually relevant to the acceleration. We're only interested in how much it's going up by each second, I guess is what we're saying here. So let's have a look at an example. We're actually going to carry on with an example that we looked at in a previous video. So we had a look at this question here, where it was a woman drives her tractor down onto the beach, and we can see it's a distance time graph, so it was accelerating, speeding up at the beginning here, and then traveling at a constant speed. So it accelerated up to a particular speed and was traveling at a constant speed. So the first part of the question asked us to work out the average speed, and so we took the total distance divided by the total time. And then it asked us to describe the motion of the tractor during section B here, and we said it was a constant speed, and it asked us to say what that meant in terms of forces. So we said the forces must be balanced for there to be a constant speed. But during C here, it then asked us to work out, it's asked us actually to calculate the acceleration, so during this first part, section A. Well, to do that, it actually breaks it down for us. It asked us to work out the speed at the end of section A, so we worked out the slope here, and we worked out that at the end of section A, here, it was travelling 8 meters per second. So that's the story so far. We've been asked to work out the acceleration during section A here, right? How much it's accelerated during section A here, all right? And we've worked out that at the end of section A, it's traveling 8 meters per second. So how do we calculate the acceleration then? Well, so we've looked at our formula just a second ago. We could say acceleration is the change in speed, the change in velocity, over the change in time. So the change in velocity in this case is our 8 meters per second. And let's have a quick look back. Let's just flick back and look at what's the time. So we worked out at the end of section A here, it's going 8 meters per second. It was going 0 meters per second. It was basically flat at the very beginning here. And that's happened over 30 seconds. So great, we can work that out now. So acceleration is our change in speed, our change in velocity, over our change in time. So in this case we've got it's 8 meters per second because it started at 0 and it's gone up to, so the change in velocity is 8 meters per second, and the time here is, it was over 30 seconds. So if we work that out, divided by 30, and we get 0.2, and it's 666, we can round it to 0.27 meters per second per second. Now, that actually then asks us to work out the net force. So that's something we looked at in a previous video, and we'll do it really quickly. But before we do that, just to recap really quickly here, the acceleration is the change in speed. So we worked out that at the end of section A it was going 8 meters per second, and since it started from 0, obviously the change there is 8 meters per second, divided by the time it took for that change. So section A was 30 seconds long. That gives us an acceleration of 0.27 meters per second, and oh, I've made a mistake here. It's meters per second. That should be a little -2 here. Alright, telling us it's meters per second. So that's saying every second the tractor, during section A, every second the tractor got faster by 0.27 meters per second. Alright, so the force part, calculate the net force. Well, force, we know from our previous video, is just the mass times acceleration. And so in this case, we've got 1660, and we can times that by our acceleration, the 0.27. And you'll get your answer. Now, there's one little trap, one little trick here that you need to just be aware of, and that's one of the reasons I left this in. When you've got a question like this, which links multiple things together, you can round your answer here. So you're allowed to round that, for instance, to 0.27 rather than, leave it, try to write out 0.266666, write all those digits. But when you use the answer in your calculation here, you should use the full value. So leave it in your calculator. Leave the answer you got here, the 0.266666, and times that by 1,660. Because you could get a slight different answer, and you don't want to get the wrong answer just because you rounded. So you can write down your numbers in the rounded form, but when you're using them or plugging them into your calculator, keep them in their original form. Don't round them. Or if you do have to type it in with as many as many of those decimal places as you can. So in this case, we times that by 1660, and our answer here, newtons, we get 442 and I'm going to just round up, 0.7 newtons, or you could even round that up to 443 newtons. And they've been nice enough to give us the unit there as well. Give that to us, so this is in newtons. Okay, so hopefully you found that helpful. Key thing to remember is that acceleration is a change in velocity over a change in time. So to work out the change in velocity, sometimes you'll actually have to subtract. You might get a question where it says Jane was driving in her car at 5 meters per second and accelerated to 15 meters per second, and it took her 10 seconds to do this. What is the acceleration? Well, you'd take the change in velocity is 10 meters per second, the 15 take away 5, it's increased by 10, divided by the time. So sometimes for your change in speed here, it's actually best if we actually look at this as, alright, well actually I'll leave that here as change in velocity. I'll just get rid of my equals there, get rid of that. Sometimes it's actually best to think of this as, alright, it's actually your final velocity, we can go VF, minus your initial velocity divided by time. So it's just making a special note here that it's the change in velocity. So here this would have been 8 take away 0, so it'd still just be 8. We've increased in speed by 8 meters per second divided by that value for time. So again, guys, hope you found that helpful. We're going to look at a few more examples in the next video when we look at some speed or velocity time graphs and where we do some more acceleration calculations there.